Now let's quickly do a question related to matrix method. These are x and these are y. X is 1, 2, 3, 4. Y is 2, 3, 5, 6. So we know the formula is x transpose x beta equal to x transpose y. So quickly we'll calculate x transpose x. X transpose x is going to be sigma 1, sigma x, sigma x, sigma x square. So this is sigma 1, which is 1, 2, 3, 4, which is 1 plus 2, 3, 6, 10. Then since this is a symmetric matrix, here also 10. Sigma x square 1 plus 4 5, 5 plus 9 14 plus 16 is 30. So we are here we have x transpose x. Now we know that beta is x transpose x inverse x transpose y. Let's calculate even x transpose x inverse. X transpose x inverse is equal to, determinant of this is 4 times 30 120 minus 100, it is 120 1 by 20. 4 times 3 30 minus 10 times 10, this is 120 minus 100 equal to 20. This is a determinant and determinant will be in the bottom. And now we know that we can calculate the inverse of a 2 by 2 matrix just by interchanging the diagonal elements and changing the signs of the left diagonal one. So it is 34 minus 10 minus 10, and this will be, and for now let's leave it like this. We are going to simplify it in future, and let's calculate x transpose y. So x transpose y is going to be, as per the formula, sigma y sigma xy. So sigma y 2 plus 3 5 10 16, and the sigma xy 2 plus 6 8 plus 15 23 plus 24 47. This is x transpose y. Let's go to the new page. And now beta is equals to x transpose x inverse into x transpose y. So x transpose x inverse is 1 by 20 34 minus 10 minus 10. 1 by 20 34 minus 10 minus 10, and x transpose y is 16 47. Am I right? Yep. Now let's multiply this. This is equal to 1 by 20. 30 into 16 is 480 minus 470 is 10. 30 into 16 minus 47 into 10. This is 480 minus 470 is 10. And this is minus 60 plus 188. This is 188 minus 160. How? Minus 10 into 16 plus 4 times 47. This is minus 160 plus 4 4s are 16, 4 7s are 28. 16 28 is 4 4s are 16, 4 7s are 28. 16 28 188. This is going to be 28. So therefore we have 1 by 20, 10, 28. Now our final answer 0.5, and this is going to be 1.4. So our final beta values is beta is equals to beta naught, beta 1. This is equal to zero point 0.5, 1.4. 0.5, 1.4. Our final regression line is going to be y equal to mx, which is beta 1x, 1.4 x plus beta naught is 0.5. Therefore, this is our final regression equation. Nice. Now, let's look at time and space complexity of this method. So let's assume that we have a data set of x which has d features, right? So how will our matrix x look like? X equal to, the first column will be padded with ones, and then we'll have first data point of first feature, first data point of second feature. It will go on till first data point of d features, and this will go on till we have nth data point of dth feature. So what is the dimension of this x? It's going to be n rows into d plus 1 columns. And let's assume we are going to call p is d plus 1. So we can write it also in the form of n cross p. And how does our y matrix look like? It will simply have one column with all the possible outcomes y1, y2, y3. It will go on till n points. So it will have just n rows and one column. This is our y, this is our x. Now, as per our formula, x transpose x into beta is equals to x transpose y. We need x transpose x, we need x transpose y. Let's calculate the time complexity required to find these matrices first. So we know x transpose x. We know that x has n data points into p features. So x transpose is going to be just the reverse of it, which is p rows into n columns. What is the order of x transpose x? X transpose x is going to be x is right, let me write it down clearly. X transpose is p cross n and x is n cross p. So therefore it is, as we know, if you are multiplying two matrices A m cross n and B n cross p, then the resulting matrix will be of order m cross p, and the total number of multiplications in this is going to be m into n into p. So here the time complexity needed to calculate this is going to be O of p np, or we can tell np square. And what will be the final dimensions of x transpose x? Right. X transpose x, the dimensions is going to be p into p. Now for X transpose Y, we know that X transpose is of order P cross N and Y is of order N cross 1. So this will take us a time complexity of P into N into 1, which is nothing but just NP. And what will be the dimensions of X transpose Y? Alright. X transpose Y is going to be P into 1. So now what do we require? Beta is equals to X transpose X inverse X transpose Y. Let's find the time complexity needed to calculate X transpose X. We know that X transpose X is of order P cross P. So to calculate its inverse, we will require X transpose X inverse. It will also be P cross P. But we know that to calculate a matrix A of order n cross n, we need n cube operations. So here will be require P cube operations. And now we know X transpose Y is of order P cross 1 and X transpose X inverse is P cross P. So beta, beta is X transpose X inverse, which is P cross P, and X transpose Y, which is P cross 1. And for this we will require a time complexity of P into 1. So we can tell P square. And the final order of beta is going to be P into 1. Beta will be a matrix of size P cross 1. Now let's shrink this perfect. Now, what is the total time required to calculate beta? Total time is going to be O of, first we require time to calculate X transpose X, which is NP square, plus to calculate X transpose Y, which is NP, plus X transpose X inverse, which is P cube, plus the final multiplication of these two matrices, which consumes P square. This is the total time required to calculate our beta. Now, what is the space complexity? Well, first we need to do the training only once. And once we do the training, we will get all the required beta values. So, can we tell that we need just the space of this matrix B? Yes. Because this matrix B is just a single vector which will store P data points and it is only one column. So we can tell OP. But now let's take a closer look at this time complexity. This is a hell lot of a time for a computer to calculate. Imagine we have some data points in order of millions or billions. N can be in the range of crores. Here we have just represented somewhat like 10,000 crores. And if we think of features, we can have nearly 1,000 features. So P is going to be nearly 1001, but it doesn't make a sense because it's just a minute change. And if we look at this time complexity, it is going in order of n p square, n p cube, p square, n p square, n p square. This will go till 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 raised to 10 and p square. Let's think it is this. So p square, here let's assume p is nearly the order of 10 cube. Then p square will be the order of 10 power 6. And here this into 10 power 6. This is going to be 10 power 16. This is a hell lot of time consumed. We don't have this much time or money to be spent in computing this. So, is there a solution? Yes. That solution is called as gradient descent. We will look in next video. Thank you.